Subjective probability is a probability that is obtained by using personal judgment. So most of life's events are not repeatable, in which case the subjective probability plays a part. When you look at this mountain, you're saying, what are my chances of making it up this mountain? You don't know because you've never climbed that mountain before, and you'll probably never climb it again. So you have no data to base anything on, so you can't make empirical, and you have no cards or dice or anything, so you can't do classical. So that means it's subjective. You have to say, I think my chances of making up that mountain are 60%. Why? Because I think so. You're making a personal judgment. Keep in mind, however, that subjective probabilities are perfectly legitimate. I make fun of them a little bit because often they're not legitimate, but they can be, or often, I should say, are frequently perfectly legitimate and are sometimes the only method of assigning likelihood to an outcome, because what you're doing just doesn't have a repeat possibility. If that's the case, then this is all you've got. So, for example, what are the chances of Brad Pitt ever winning an Oscar? You make a subjective guess, right? And some people would be making a very wise guess, like if they're big in the industry or whatever. But if they're not big in the industry and they're just guessing, then that's less legitimate, right? So it just kind of depends on the person making the guessing as well. All right, so let's suppose during the World Series of Poker broadcast on ESPN2, which is very fun to watch, I highly recommend it, they flip over their cards, and then on the screen it'll show the person's percent chance of winning with that hand. So you see their cards and they say 88% chance right by their name on the screen. What kind of probability is that? And that is very much a classical probability. They have a computer basically that sits there and knows, oh, he pulled up a 7 and an 8 of diamonds. That means this is his chance of winning, or her chance of winning. So it's a classical probability. It's totally based on cards, gambling, everything equally likely. All card hands equally likely, right? Now, what about the probability that the Red Sox will beat the Yankees in their next game? Well, you have some past data, but the thing about it is that the lineups are constantly changing, the workouts are constantly changing. It's not exactly the same. It's not the same as in the way cards are the same. So this is actually more a subjective probability. So when the ESPN people get on, they say, well, the chances of the Red Sox winning this time are blah, blah, blah. What they're really basing that on is their personal judgment. They've been watching the team practice. So-and-so is out with an injury. So-and-so is back in, et cetera, et cetera. It's raining, it's cold, it's not cold, et cetera. Because all those conditions are constantly changing, you're unable to completely replicate every single thing about that game, which means it's a subjective probability. All right, now the probability that the next person that walks into the Red Cross will have a blood type of O negative, which is something Red Cross really likes to know about because O negative is a universal donor. That would be an empirical probability. So what the Red Cross does is they actually track the people that donate blood and the people that have blood drawn and taken in the hospitals. And they know that in a particular region, it's this percent O negative, this percent A positive, and so on. And actually, if you ask the Red Cross, they will give you the numbers that they've got because they track it so carefully. They track it from region to region. And therefore, they know, hey, if you walk into the hospital in Jackson County, they know your chances more or less of you being O negative, you being AB positive, and so on. They have data records to base that future person walking in on because they need to. Otherwise, they would run out of the types of blood that they need. And at the end here, I have a little XKCD comic, which is very generously, they let us post here in the notes. And it just shows you how this was kind of sad. The person that makes this comic had this real life situation happen, and they had to make medical decisions for his significant other at the time about her medical treatment for, I believe it was cancer. And they were looking at prognoses of 81%, 77%. Those are probabilities. They're to some extent empirical probabilities because they're looking at, her gender, her age, her health, et cetera, and they're making, diagnoses and saying, hey, you have an 81% chance of surviving 5 years. And the person that makes the comic said, probability used to be my favorite branch of math because it had so many real life applications. And that's something to keep in mind. Probability can seem very divorced from real life because it seems like it's all gambling and stuff. And it is gambling, so it does have that effect. But it's also more than that. It's also medical decisions. Prognoses, when you're given those percent chances of survivals over time and such, that's all probability. And so it's very much tied in to what we're doing in this chapter, indirectly and directly. Those are generally empirical probabilities, but we all have to make those medical decisions for ourselves or our loved ones later in life. And so probability is perhaps more prevalent in your life than you might realize, even if you're not a gambler like me. I'm not a gambler either. All right, we're all done with section 5.1. I'll see you back here for 5.2.